of Jan and it's a Sunday. Okay, so where did we end in the last class? We ended at some questions on how right to expression for the equilibrium constant. Okay, expression for the equilibrium constant. So we have, we now know that there are two ways to express the equilibrium constant. First is Kc and the other is Kp. So now what we are going to do, we're going to derive a relationship between Kc and Kp. Okay, Kc and Kp. So write the topic title: relationship between Kc and Kp. Okay, relationship between Kc and Kp. Now, first of all, a bit of prologue here, that PV is equal to nRT. We know that PV is equal to nRT. So rather here, what we are doing now, we are doing Kc and Kp. Don't worry about Kc and Kp. You worry about how the K are expressed. So K are expressed as the concentration and pressure. So rather than what we are finding essentially is not the relationship between Kc and Kp. We are finding a relationship between the concentration and the pressure. Concentration and the pressure. Okay. So we have PV is equal to nRT for gases, and obviously we will not be writing anything about Kp if we don't have gases. So we are always talking about gases when we talk about Kc and Kp, both of them. Okay. Now if we are just talking about Kc, that means we can have anything other than, we can have anything which is other than gas also. So in this case, we are just finding the relationship between the pressure and the concentration. So we can write pressure is equal to what? The number of moles divided by volume times RT. Number of moles divided by volume times RT. And number of moles and volume, if you remember, number of moles divided by volume. And if I talk about volume in liters, this is equal to what? The concentration on molar concentration. Molar concentration. Yeah. So we have a relationship that P is equal to what? The concentration times R times T. Now, for example, if I want to talk about the pressure of A, I can say that it is equal to the concentration of A times R times T, and I can write this as the concentration of A times R times T. Any doubt till here, guys? Yes or no? Tell me.
No, sir.
Okay, fine. Now let us start. So let us look at the derivation completely, and then we will. Then you can write it down. Okay, then you can write it down. So I will write the Kp is equal to the pressure of A to the power A. So we are writing this for the generalized reaction that we have seen many times now. AA plus BB is going to give me CC plus DD. But we have to write here what? The products, not AA. We have to write here DD and the pressure of, I should be alphabetical, CC times pressure of DD divided by the pressure of A to the power A, pressure of B to the power B. Now, as we know, since pressure of anything I, which would be equal to the concentration of I times R times T, so I can write that PC is equal to what? Write this as the concentration of C times R times T to the power of C, and I can write about D as the concentration of D times R times T to the power of D. Similarly, for A, I can write that the concentration of A times R times T to the power A divided by concentration of B times R times T to the power B. Now, I can assemble C, D, A, and B in one place. I will write C into the concentration of D. Wait a second. I need to put here a C times D to the power of D divided by concentration of A to the power A divided by the concentration of B to the power B. Now, for the RT parts, what I can do, I can write that RT to the power C plus D, because both of them are RT. So we have a power x into b, a to the power x into a to the power y, which will be equal to a to the power of x plus y, right? Similarly, I can write rt to the power of a plus b. Now, in this case, I can expand and I can write that so acha, we can not write this, rather I should write this c to the power c, d to the power d, a to the power a, and b to the power b. Okay, so what is this? This is kc, right? This is nothing but this is kc. So we'll write kc times rt. Now both of the numerator and denominators are same, so I can write rt to the power of, so c plus d is above, so I will write c plus d. Okay, c plus d minus a plus b. Okay, minus a plus b. I can write the same thing as the kc times rt to the number of moles of product of gases. Okay, number of moles of products, number of moles of gases of products minus the number of moles of gases of the reactant, and this can be written as kc times rt to the power of delta n, number of moles of but gas, because we are talking about kp. So we have derived a relationship in which kp, it is equal to the kc into rt times delta ng. Okay, delta ng. Okay, then what is ng? Ng is equal to the difference in number of moles of gases in products minus reactants. Okay, so let me just zoom a bit out and then you can write. Let me know if I have to scroll a bit up. Okay,
Sir, could you like show the intro part again? Yes, okay.
okay. Raise your hand if you're done. Okay. Only Khalid is done. What about others? Okay, Hamza is done. Hiba and Nahra, waiting for you. Nahra is done. What about Hiba? Okay. Yeah, you guys can lower your hand. See. Now, so we have delta ng, right? We have delta ng. The difference between the number of moles of gases in products and reactants. Okay, so please listen, don't write now. So this can be either the delta ng can be greater than 0, right? It can be greater than 0. Delta ng can be equal to 0. And the difference in the number of moles of gases in the products and reactants, delta ng, can be less than 0, right? Less than 0. Now, if it is greater than 0, that means in the products we have more number of gases. Here means products, P means product has more moles of gases. Okay, here equal, here the products and reactant have equal moles of gases. Now this is completely theoretical. You don't have to think about any experiments. Number of moles of gases means according to the chemical equation. Okay, according to the chemical equation, you don't have to look at the number of moles, exact number of moles. Okay, we're just talking about the chemical equation. You look at the chemical equation and you can just count. Now, if delta Ng is less than 0, it means that product has less moles of gases, right? Now, in this case, what is the relationship? The relationship for all of these cases is that the Kp, it is equal to Kc into RT times delta Ng. Now, if Ng is greater than, if it is, Ng is what? If Ng is greater than 0, that means it is positive. R is also positive. T is also positive. Temperature can never be negative, right, in Kelvin scale. Hence, what you can say that in this case, the Kp is greater than Kc. Now, in this case, what is going to happen? The Kp and the Kc are equal, because if delta Ng is equal to 0, RT to the power 0 will be equal to 1, and hence Kp and Kc will be equal to 1. And in this case, the Kp is going to be less than Kc. Okay. Now, with that in mind, let me put up a question for you guys. Yeah. So first of all of you have to tell me the delta Ng here. Okay. All of you, please calculate the delta Ng for all of these reactions. What it is. Okay. So it will be either 0 or 1. I mean 0 or more than 0 or less than 0. No one? Are you guys doing this? Yes or no? Hamza, Hiba?
Yes, sir.
क्या नहीं हो रहा है क्या? You have to count the number of moles of gases, in the products minus reactants. So tell me, what is the answer for the first one? A, Hamza? How many moles of gases in the product? Hamza? Okay.
Sir, 2.
Now tell me. 2 moles, okay. And how many
Yes.
moles in the reactant? How many moles? Sorry?
Sir, 2.
Did you say something? नहीं जोर से बोलिए ना जरा.
Sir, 2.
2. Yeah. So 0. What about here? In the B part? How many moles in the product? Hiba, you tell me. How many moles of gases in the product, Hiba? In the second question?
Sir, 2.
2. And how many moles in the reactant?
2.
So equal to 0. क्या हो गया? अब इसमें Khalid, you tell me in this one. N2O4. Number of moles of gases in the product? Yes, Khalid.
Yes, sir.
Number आपको आवाज आ रही है कि नहीं आ रही है ये पहले बताइए आप.
Yes, sir.
So you heard my question?
Yes, sir. What
Whatever
are the number of
Ah.
moles difference?
You tell me then.
2 minus 1.
2 minus 1, yeah. So this will be equal to 1.
1.
Okay. Who wants to answer for the D1? Nehra, can you answer? Imran, I did not hear you guys speaking anything. So can you please turn on the mic on and tell me if you can speak? No? Okay, then we have Salman. Salman? Salman, can you tell me number of moles of gases in the product for the D1? Salman, can you turn the mic on or what is happening? Can you answer in the chat at least? Nehra, you're also not here? Salman, can you please write it bit? Okay. 2. Nehra, can you please speak?
Yes, sir.
How many, tell me, in the products, how many are there? How many moles?
2.
2 moles. And in the reactants?
2.
Why 2? You see SO2 and O2, that is why 2? Nehra,
Yeah.
why did you say 2? Okay, but we have 2 moles of SO2, na?
Yeah.
So it will be how much? 3, na? 2 plus 1.
Okay.
Okay. Arey, okay kya? You understand
No,
this,
I
right?
understand.
Yeah, okay,
Yeah,
fine.
sir.
So this will be -1, right? So it will be -1. So now you tell me which of the option is correct. What they're asking, in which of the following relationship Kp. So here it is what Kp is equal to Kc. Here also Kp is equal to Kc.
Last one.
In this, yeah,
The
in this case, what
third
is there? And in this case, Kp is greater than Kc, na? Kp is greater than Kc here, right? Because it is positive. If Ng is greater than 0, that means you will have Kp is greater than Kc. In this case, the Kp is less than Kc. So the D option is the right answer. Yes or no? Yes or no, guys?
Yes, sir.
Okay. Now, right, next question. Now, wait a second. Let me give you some. So we have R. So please write a note here, which is important. Units of R. Okay, units of R. So, right, if pressure is given, in ATM, then R is going to be equal to 0.0821 liter ATM per Kelvin per mole. Per Kelvin per mole. If pressure is given in bar, then R is equal to 0.0831 liters, liter bar per Kelvin per mole. Okay, so please write this down. Let me know if you're done. Now write another question. So here you have been given the value for Kp. Yeah, okay, you have to ask you have asked the value of Kp, you have been given Kc, right? You have been given Kc is 26. For the reaction, PCl5 is giving PCl3 and PCl2 at 250 degrees Celsius. So you have to calculate the Kp for this reaction. So you have the relationship now, Kp be equal to Kc. You write 26 here into RT to the power delta Ng. So first of all, you have to calculate the delta Ng, okay? You have to calculate the delta Ng. So calculate the delta Ng and tell me in the chat what is the delta Ng. Yes, call it correct. So this, they have said that this is 250 degree, okay? So it is not Kelvin. First, you have to also change this to Kelvin. Remember that. Okay, Nara, we will see. Nehra, can you send the answer to Nishka? Do you have Nishkar's number, Nehra? Nehra, do you have? Yes
Sir,
or no?
who's?
Nishkar sir? No?
Sir, I don't know. No.
Achha, how do you get the links and all? Yes, Nehra, how do you get the links? Nehra, how do you get the links?
Sir, I get it in WhatsApp, but I don't know whose number that is.
So that number, that is 93102, na? So what you need to do, you take a photo of whatever you have done in the calculation and send it to me now. Not me,
Okay, sir.
but that number. Okay, the Learnivio number. Okay.
Okay, sir.
हमजा आपका डेल्टा एनजी सही नहीं है। ये समझा, सी और डेल्टा एनजी ना। Hamza, you calculated NG, delta NG?
Yes, sir. Sir, it should be -1 itself, right?
Why? Tell me, number of moles in the product.
So 1.
Number of moles in the product.
Sorry, 2.
Now you tell me. Got it, no?
That's product.
So see, the reactants and product, it is in our hand, right? So this is the reactant, this is the product.
Okay.
What are the reactants? So reactants is something that you write on the left hand side. On the right hand side, you have write the products. Hana?
Yes, sir. Understood.
Got it. Okay. So so when we have equilibrium in this case, so I mean any of these can be reactants and any of these can be products. If I am writing in this way or I'm writing in that way, both of these are reactions only. Both of these are reactions. Nothing is going to change. It is just that we are expressing it in a different way. That means that Kc and Kp, they will be altered. That is true. Reactants and products have been changed. Yeah. So whatever you had done, that is right. I mean, this question, I specifically gave this question to test something. Yeah. So the first thing is that should say, sir, none of the option is right. Why? Because if I look at the delta Ng and I write the products minus reactants, so this will be 2 moles of products minus 1 mole of reactant. That is equal to 1. And as we see that delta Ng, it is greater than 0, and hence the Kp should be greater than Kc, right? Kp should be greater than Kc. And all of the options that are given here, they are less than 26. That is why none of the options are correct. Okay, none of the options are correct. Nehra, आपने तो भेजा नहीं अभी तक. Yes, Nehra?
Sir, I already sent it.
So you have sent it? Okay.
Yes, sir.
Okay. You also took -1? Yeah, so right, है ना? Tell the answer now. Just giving you an option to what you will take the R. You take the R as 0.0821. Okay, because it is ATM. Generally, we do calculations in terms of ATM. Oh, is it a single tick? Nehra, is it a single tick?
Yes, sir.
Sunday, that is why that number would be off. Okay. What happened, guys? I'm not getting any answers. Kya hua? Khalid, Salman, Hiba. Are you guys calculating? It is simple, na? Hiba? Hiba and Hamza, what happened?
Sir, I
Sir,
sent you.
are you that constant or the reactant R in the formula?
हाँ, ये देखा हमने क्या लिखा है आपको? Did you see this? Units of R, Khalid.
Yes, sir.
What is this R? Okay, one more thing. This R, it has come from where? Here, na? What is this R? Khalid?
Okay, universal gas constant.
हाँ भाई, थोड़ा ध्यान रखिए, क्या हो गया?
I got confused in that only, sir.
अच्छा. हाँ, so you made a mistake, Nehra, in the delta Ng part. Okay. ये डायरेक्ट आपका आंसर 0.061 आ गया बिना कैलकुलेशन के, नेहरा. हाँ.
Sir, I wrote it again for sending you.
नहीं, वो हम तो नहीं चाह रहे थे ना. That I did not tell you. So send the real one, whatever you had done. I don't want fair. हम marks देने वाले तो ही ना आपको. I want to see how you are thinking and how you are doing the problem. So send me the page where you have written and calculated for the first time. अरे आया आप लोग का आंसर, क्या आंसर ही नहीं आ रहा है आप लोग से। तो वो भाई मल्टीप्लिकेशन करने में इतनी दिक्कत हो रही है, हियर वी डोंट इवन हैव एनी पावर, जस्ट हैव टू मल्टीप्लाई आर एंड टी। Still waiting for answers. What happened, guys? आप लोग आंसर भेज रहे हैं कि नहीं भेज रहे हैं? हमजा, are you doing this? Yes or no?
Sir, I sent you answer long back.
So that is the wrong answer, no?
Okay.
Didn't I say that if okay? Tell me, Hamza. Wait a second. Where are you? हाँ, कहाँ आपका दिमाग कहाँ है? देखिए, delta ng is what, greater than 0 or less than 0? Tell me, Hamza.
Less than 0.
So, but
Sorry, greater than 0.
so, and you did the calculation using minus
Yes,
1,
sir.
right? So it
Yes,
would be
sir.
wrong, na? It would be wrong, right? अभी तो हमने कहा ये बात आप and what about you, Hiba? Yes, Hiba. What happened? Can you not turn the mic on?
Sir, could you show the calculation, please?
Calculation. अरे हमने तो अभी तक जवाब ही नहीं बताया. None of these options are correct. That's what I'm saying.
Okay.
You tell me the answer, ना? You calculate. आप options में मत जाइए अभी, है ना? You have just said that delta ng is greater than 0 and hence kp should be greater than kc. None of the options are greater than 26. And Mehra, are you there? Yes. Yeah, approximately that is right. Correct, Khalid. What happened? Is Hiba not here, Hamza?
Yes, sir, she is here.
But why is she not answering questions or anything?
Maybe her mic is not working. I'll ask her to rejoin.
Ask her to rejoin. No? I don't know whether she can hear me also or not. She can use the chat. She's not also answering in the chat. Yes, correct, Salman. What about Nehra? Nehra, you got the answer right or yes or no? Are you still on the same answer, thinking that that is right? Yes, Nehra, can you please answer me? I've asked you many times something. And what about Imran? Is Imran here? And I see how much time you guys like spend for doing a simple calculation that will not even come in your examination. Anna? So I mean, you will be getting a bit more difficult questions than these. Okay, you will now not be getting. This will be for 1 marks or so. So Nehra is not here. Imran is not here. Okay. So I've got one more answer. Hamza, can you please turn the mic on?
Yes, sir.
You tell me, what did you take? अभी तो हमने बताया आपको कि KP will be greater than KC. What is the KC? 26 ना? It will be greater than KP will be greater than KC ना? Because delta H is greater than 1, greater than 0, sorry.
Yes, sir.
So what are you doing wrong in calculation? Please tell me. What did you take R as? What did you take R as?
0.0821.
Okay. So what went wrong? So
Okay, I understood, sir. I understood now.
equilibrium is going to break your hearts very hard because when you try to learn the concepts, they are going to be very easy. The calculation, you will be struggling with the calculation. If you're not good at multiplication, simple multiplications of 3 digits, 4 digits number and decimal pointers, then it's going to break your heart, okay? And you're going to lose mind. Yes, now Hamza, you are correct. What about Hiba? What happened? Hiba, can you please answer in the chat at least? Are you doing this question or not doing this question, or are you having any difficulty? Fine, I think you need a few more questions. Okay, I'm still waiting for Nehra's answer and Imran's answer. All right, this question.
Sir, could you show the starting of the question?
This is the starting of the question. There's nothing else. So they have given you KP. They have also given you the pressure at which they're doing this, calculating this KP. They have given you the reaction, and they're asking to calculate you the KC. Okay. Okay, Khalid, let me see. Mm, can you maybe write the units? Think about the units maybe. Your answer is correct. Yes, Hamza, correct. Maybe think about the units now. Think about the units. Waiting for Salman, Hiba. Okay, fine. We also got the answer. So you did not have to do much. So we have the relationship that Kp is equal to Kc times Rt into delta Ng. Yes, Salman, correct. Now, we have the Kp here. We need to find the Kc. So the Kp is 0.057 ATM. That is, we will consider that later. But first of all, we write to delta Ng, which will be equal to 2 minus 1, which is equal to how much? Which is equal to 1, right? So 2 moles, and here we have 1 mole. So we'll write. Now we need to find the Kc, right? We need to find the Kc. So Kc will be equal to Kp upon Rt times delta Ng. Now Kp is 0.157 ATM divided by what is Rt? R is 0.0821. May write that or not? Write that 27 degrees Celsius. That means 300 Kelvin. Okay, 300 Kelvin. Now, if you look at the units here, okay, so let me write the units. Since all of you have got the numbers right, so 0.0821 liter ATM per mole per Kelvin into 300 Kelvin. So Kelvin and Kelvin gets cancelled. ATM and ATM gets cancelled. So whatever you are getting now 0.00637 into that will be this liter is here. Mole inverse will go above and it will become mole. So mole liter inverse. Okay, mole liter inverse. This will be the unit. So right, Kc is equal to 0.0637 mole liter inverse. Done, guys? Done? Can I move? I hope you have written this, right? So write a note now. Equilibrium constant, both Kp and Kc don't have Kp and Kc don't have any units if the number of moles of reactants and products are equal. Kc and Kp would have specific unit if the number of moles of reactants and products are not equal. Okay, if they are not equal. So write these 2 points in the notes. So we have just seen that. See, in this case, the delta Ng was, sorry, the number of moles of the reactant product doesn't mean we are talking just about gases. Okay, doesn't mean we are just talking about gases. I'm talking about pure number of moles of products and reactants. Since here there was a difference, the products and reactants, they did not have the equal number of moles of substances. Hence, we had some unit for the Kc and Kp. Okay, write this down. Let me know if you're done. Done? Yes or no? Tell me fast now, guys. Don't be lazy like this. Done?
Done, sir.
Hamza, Hiba, Khalid.
Yes, sir.
Okay. Now, right. So the equilibrium reactions that we have seen till now, they can be classified into 2 parts. Okay. So the equilibrium reactions, we can classify the equilibrium reactions into 2 parts. There are some in which we have homogeneous equilibrium. There are some in which we have heterogeneous equilibrium. Okay. So in homogeneous equilibrium, the important point is that the products and reactants are in same phase, and in this we have products and reactants. That means products and reactants, all these chemical species. Wait a second. all products and reactants are in same phase, and here you can write the products and reactants are not in same phase. Are not in same phase. Okay. You can write this down. Turn your mic on if you are done. Okay, then answer me A, B, C, D. So for the A, you have to tell me whether it is heterogeneous or homogeneous. Similarly for B, C, D, and E. Yes,
Can
Hamza,
I
tell
tell?
me.
Yes, sir.
Yeah.
The first one is
Okay.
homogeneous.
Okay, second one.
Second one is also homogeneous.
Okay. Third one.
Third one is heterogeneous.
Heterogeneous.
And fourth one is also no, it is homogeneous.
Okay, very good. Paying attention. Okay, what about the E case?
Side is hetero.
All right. So just I want to mention that this is aqueous and water. It means obviously it is aqueous, right? That is why both of these. So I mean, liquid is not some other phase. Aqueous means water only. So this is also aqueous. This is also aqueous. That's why this is all homogeneous. Okay, this is all homogeneous, not heterogeneous. Write this down. Raise your hand if you're done. Waiting for Khalid, Salman. Salman is done. Okay, now just write a note. By convention, the concentration of pure solid and liquids. Pure solid means such as here we have H2O liquid, and that means it is pure liquid. Here we have FeOH 3 whole thrice. That means that this is what? This is pure solid. So by convention, the concentration of pure liquid and pure solid are taken as unity, that is 1. Unity, that is 1. Okay, that is 1. So whenever you have anything which is solid, and its concentration will be equal to 1. The concentration of liquid, it is also going to be 1. Okay, I'm not explaining this right now. I want you guys to find the reason why it is like that. Okay, find the reason. Now just remind me on Saturday's class, and I will discuss why we take the concentration of pure solid and pure liquid as 1. Okay, as 1. So for example, if I want to say that you have CaCO3, okay, and this is in solid state, it is getting converted into CaO solid plus carbon dioxide gas. Now for this, you will be tempted to write the Kc as the concentration of CaO times CO2 divided by the concentration of CaCO3. But since CaO is also what? Solid, is equal to 1, and the concentration of CaCO3 will be equal to 1 as per convention. Hence the Kc will be equal to only the concentration of CO2. Okay, will be only the concentration of CO2. Okay, so please write this down. Let me know if you're done. Okay, Hiba is done. Hamza is done. Waiting for others. Imran, Khalid, Nehra, and Salman. So now this is your homework, okay? Yeah, scroll up. Okay, fine. Right.
No, sir, I was saying done.
After done, okay. Okay, so you have some expressions here, chemical reactions. Just take a screenshot. Now this will be uploaded in the for the assignment, but also take a screenshot. You have to write the Kc, huh? So as we did in the last class, so you have to write the Kc. For example, for the A case I'm writing, for the A, how will you write this? The Kc will be equal to, so this solid you don't have to consider, this solid you don't have to consider. So you will just write the concentration of CO2, okay? So just take care of that. Also see here that it is H2O. H2O means water, that is liquid. You don't have to take this. Similarly, this liquid, you don't have to take this liquid, okay? So keep in mind these things, and then you have to write till A, B, C, D, E, and F, okay? You took a screenshot?
Yes, sir.
Yeah, okay. Now let us write the applications of equilibrium constant, okay? Write the application of equilibrium constant. But before that, write a remark, that is a topic which is known as reaction quotient, okay? Yeah, sure, Salman. Done, Salman? Okay. So write reaction quotient. Reaction quotient. the ratio of concentration terms of reactants of products to reactants raised to their stoichiometric coefficients is generally called reaction quotient and represented by Q. So what is Q? Q is same thing, that is the products, the P and the multiplication of those products divided by reactants power R. Okay, this is the same thing. You may be thinking that it is similar to the equilibrium constant, okay, but it is different. It is different. Why? In equilibrium constant, we have the concentrations at the equilibrium point. We have the concentration of equilibrium, but at any point, the concentration, if the concentrations are changing, and if the concentration they have not reached, the reaction has not reached the equilibria, at that point of time, when we calculate the reaction quotient, it is known as reaction quotient. When we calculate the ratio of concentration terms to the products of the products to the reactants raised to their stoichiometric coefficients, those are known as, that is known as reaction quotient. Okay, that is known as reaction quotient. But if I calculate the reaction quotient after or at equilibrium, then that is known as the equilibrium constant. That is known as the equilibrium constant. Okay, so this is generally the case. This is generally the case, but at equilibrium means after a very long time. Equilibrium, the Q, it becomes equal to the K. Okay, Q, it becomes equal to K. Q is equal to K. You got this point, yes or no? So if I want to write the K now, so a better way of writing K would be the concentration of products at equilibrium raised to their power and the products of reactant at equilibrium raised to their stoichiometric coefficient. You understand the difference, guys? Yes or no? Tell me. Hamza, Hiba,
Yes, sir.
Yes. So anywhere, if you are not in the equilibrium, that means it is Q. If you are at the equilibriums, then the Q becomes K. Then the Q becomes K. Okay. So write this down. Then we will write the applications of equilibrium constant. Done, guys?
Yes, sir.
Okay. Now, this whole thing that I'm going to teach you, you have to keep this in a box or something. No, this is not related directly. Here, what you are going to do, you're going to understand what does equilibrium mean. Okay, what does equilibrium mean? So maybe you can write this or you can keep this in your mind. That doesn't matter, but please listen very carefully. Okay, don't write until I'm done. And please answer me. So keep your mics on. Okay, keep your mics on. We have a simple general case of equilibrium. A is giving me B. A is giving me B. And I'm saying for this reaction, the K is equal to, let us say, the K, it is equal to 1. The K, it is equal to 1. So what does this mean? K is equal to 1. It means that, it means, I can also write now, K is equal to the concentration of A divided by the concentration of B. No, I've written the opposite, sorry for that. Concentration of B divided by the concentration of A, okay, which is equal to 1. And for that one, I can write this is equal to 1 by 1. Okay, it's equal to 1 by 1. It means after a very long time, equilibrium का मतलब क्या होता है? Equilibrium means after a very long time, what is happening? है ना? What is the scene? What is the scene? What is the case? What is the situation? What is the state of the system after a very long time? So what is the system? The A and B system after a very long time. After a very long time, for each mole of product, for each mole of reactant, we have 1 mole of product. Yes or no? Do you understand this? For each mole of A, we will have 1 mole of B. If A is 20, then B should also be 20 at equilibrium. Yes or no, guys?
Yes, sir.
You understand this, all of you? Hiba, Khalid, Salman?
Yes, sir.
Yes, it
Yes,
means
sir.
that. It means that after a very long time, अच्छा ये very long time, it is a relative word, okay? ऐसे नहीं कि मतलब आप मतलब century समझ लें. Like for example, if I talk about humans, then a very long time for humans will be somewhere around 80 to 90 years. But if I talk about a paneer, then a very long time for paneer will be 2 or 3 days and it is gone bad, right? So very long time, it is relative. It is relative to the system that we are looking at, okay? It means that after a very long time, for each mole of reactant, there should be 1 mole of product. Okay, so this is a very simplistic case that you can remember in your mind to get a feeling of what is equilibrium constant. So now you understand and now you feel now what is equilibrium constant. It is nothing like abstract thing, right? You understand now. Yes or no? Tell me what it is
Yes,
representing.
Yes, sir.
Anna, you are getting the information. Okay, you are getting the information about equilibrium constant. Now you may write this thing or you don't want to write, then don't write this thing. Just let me know. Okay, then let me know. This is something that you need to remember, but always, okay, you need to always remember. Now you write the applications of equilibrium constant. Done, guys?
Yes, sir.
Okay, so write the application of equilibrium constant. First of the application is predicting the extent of reaction. Predicting the extent of reaction. Extent of reaction, what does this mean? It means that if I say, you imagine it like this, okay? You have A and B, right? So A has to convert to B. A ko, what has A to do? A has to cover a journey and then, okay, Salman. Okay, no problem. Let me know if you're done in the chat. Okay, done. Yeah, done. Okay, fine. So extent of reaction mean A has to cover a journey and it has to reach to the point B. Okay, you imagine it like this. That means if I start with 10 moles of A and all the 10 moles of A, they reach B. All the 10 moles of A, if they reach B, then what I will say, the extent of the reaction is very high. If first, let us say the reaction is not happening. If we have 10 moles of A and after a very long time, we still have 10 moles of A, that means the extent of reaction is very small. So now you understand what does the extent mean? Tell me, you understand this word now, extent?
Yes, sir.
Yes. How far a particular reaction can go, okay? How far a particular reaction can go. But we will always look at from the reactants, what we have written, okay? We will start with reactant, that is, what is reactant? In a chemical equation, The chemical species which are present on the left side, those are reactant, and on the right side, they are the product. It doesn't matter what the sign of equilibria is there, or we are having the sign for the reaction. Okay. So the first thing that we said is the extent of reaction. Extent of reaction. Okay. Now, right, the K, for the extent of reaction, we have divided the K into 3 parts. And we say that if the K if the K is greater than, let us say if the K is smaller than, and it is very weird to write the inequality. Wait a second, let me stop sharing this screen and let me reshare this screen. Yeah. So if K is less than 10 to the power 3, okay, if K is less than 10 to the power 3, now you have to write, or rather I should say 10 to the power minus 3. Yeah, if K is less than 10 to the power minus 3. That means what? If I say, let us say K is equal to 10 to the power minus 3, then I have K, it is equal to 1 upon 10 to the power 3. That means 1 upon 1000. That means I will compare this with A upon B. No, B upon A. So we have reactants which is A and the product is B, right? Don't write these parts, just write till here. B upon A. So for 1000 moles of A, we have 1 mole of B. Yes or no? Tell me you understand this now. Okay. If K is less than 10 to the power minus 3, it means that you understand this ratio, yes or no? Hamza, Hiba,
Yes,
Khalid,
sir.
Salman. Yes. So what does that mean? Reaction hua ya nahi hua? What do we have more, the products or the reactant? What do we have more? We have products more or the reactant is more? Reactant is more. Then what does this mean? It means that the reaction did not take place now.
Yes, sir.
So reaction hardly took place, and in this case, what will be dominant? The reactant is dominant. Reactant predominates. And reaction hardly takes place. Okay. And there will be an extreme case. And there will be an extreme case where I will say the K, it is greater than 10 to the power 3. Now, in this case, you can write K, it is equal to 1000 by 1, which is equal to B upon A. Now you tell me, what will be predominant in this case? Products, right?
Products.
Product predominates. And here I can say the reaction is almost complete, is almost complete. You can have another case in which I can write the K, it is greater than 10 to the power minus 3, but it is less than. Arey yaar, this should not happen itna times na. Power where aise atak jata hai. Wait a second. Does this happen with physics class also?
No, sir.
No. Why does it happen with me? When it starts to sync now, then it gets stuck for a while. I mean, these tab here, this tab here gets stuck. Okay. So if I have K, which is greater than 10 to the power minus 3, but it is smaller than 10 to the power plus 3. In this case, both reactants and products are present in appreciable amounts. That means measurable amounts, okay? Appreciable amounts. Appreciable amounts. Done, guys?
Yes, sir.
sir.
Done.
Done. Second is predicting the direction of reaction. Predicting the direction of reaction. Okay. No. I'm starting to give you an example. Please don't write this. Okay. Please don't write this. It's the same thing that we have A, which is getting converted to B. Okay. We have A and B, which are in equilibrium. And we have K, which is equal to 1. We have K, which is equal to 1. Okay. That means what? It means that at equilibrium, that means after a very long time, if I start, I mean, it doesn't matter what I'm starting with. I'm starting with 20,000 moles of A, or I'm starting with 2 moles of B. It doesn't matter what I'm starting with. After a long time, the number of moles of A should be equal to the number of moles of B. Yes or no? Yes or no, guys?
Yes,
Tell me.
sir.
Okay. So let me say that at initially, I took A. I took 20 moles of A and I took 5 moles of B. Okay, I took 5 moles of B and I kept that in a closed vessel. Vessel, and I wanted it to reach equilibrium. I wanted to measure what would happen. But I know this, that K is equal to 1. I know that the K is equal to 1. Then what do you think? What is going to happen? Will A be getting converted to B in a faster rate, or like what would be happening more? A getting converted to B or B getting converted to A? Tell me. What should happen here in this case?
Some from B to A.
From B to A. Okay. So B to A, it is getting converted. That means B will get 4, then A will get 21, then it will get 3, 2, 1, right? So till where should it stop? This will become 22, 23, and 24, and then it will become 0, and this will become 25. So that's what you are seeing?
Yes, sir.
Hamza? Okay. So now let us calculate K. So K will be equal to, what is this? 0 divided by B 0, na? And divided by 25. So that is not matching the case. Yes or no? That is not matching, na? At equilibrium, what is going to happen?
Yes,
Now
sir.
you say once again, what is going to happen is that the number of moles of A should be equal to the number of moles of B at equilibrium. Yes or no? If K is equal to 1. Please remember that I am taking K is equal to 1. Now K can be anything, but at this point, for generalization, I'm taking K is equal to 1. If K is equal to 1, that means the number of moles of A should be equal to the number of moles of B at equilibrium. That means after a very long time. Yes or no? Yes,
sir.
Khalid, Hamza, Hiba. Hiba, आपको आ रहा है?
Yes, sir.
Okay, so now you guys tell me, now you guys tell me what should happen. What is more? That should get less, and what is less? That should get more. Yes or no?
Yes, sir.
So what will happen? A will be getting converted to B. Yes or no?
Yes, sir.
More and more, A will be getting converted to B. So slowly the amount of A will be decreasing, amount of B will be increasing, and at some point of time, they will be equal, and they will be equal. And at that point, you can say that the equilibrium has been maintained. Now we have reached the point of equilibrium. So in this case, let us try to see how we do this and how we generalize this thing. We write the QC. Okay, we will write the QC. That means, what is the Q? Because it is not in equilibrium. Initially, we are taking it is not in equilibrium. That's why we are writing QC, which is equal to 5 upon 20. Now B upon A. So this will be equal to 1 upon 4. Don't write these things. Secondly, let us take A is equal to 5. Now in this case, what was happening? Forward reaction. Right? A was converted to B, forward. Now if I have and B is equal to 20, now what will happen in this case? Backward reaction, yes or no?
Yes, sir.
We'll have backward reaction. And what is the QC? It is equal to 20 by 5, which is equal to 4. Correct?
Yes,
Yes
sir.
or no? Now let us compare these things with the K. Now in this case, whenever you are going to have the QC which is smaller than K, if the QC is smaller than K, That means you are going to have a forward reaction. If QC is greater than K, then means you are going to have a backward reaction. Yes or no? Can we generalize this thing?
Yes, sir.
Okay, so now you write. Okay, now you write. Number one, there can be a case in which QC is what it is, less than KC. Now, if QC is less than KC, that means forward reaction will take place. Secondly, if I have QC, which is greater than KC, then backward reaction will take place. Secondly, if QC it is equal to KC, then no reaction will take place. That means equilibrium achieved. Equilibrium achieved. Okay, so forward, I mean, you can also write it as forward means toward rightwards. Okay, right direction, left direction. You may see those terms also. Okay, you may see those terms also. Done?
Yes, sir, done.
Okay, so all right, the third thing that we will be discussing in the next class, the third application, which is the calculation of equilibrium concentration of reactants and products. Okay, of reactants and products. This we will be discussing in the next class. You may write this or don't write this. Now you have one thing that you need to copy. So we have learned everything about the equilibrium constant. One application is left, but you know in theory what is the equilibrium constant. Okay, so for that you need to write some of the characteristics of equilibrium constant. So for that, you need to just copy something, so maybe that I can write the whole thing for you guys, but I've already written it. That is why just pasting this here.
Sir, are you sharing your screen right now?
No, I'm not sharing my screen right now.
Okay.
But I will eventually share my screen. So you write the topic, characteristics of equilibrium constant. Well, so these are simple points that you write this, if you have doubt in any one of these points, then you let me know. What in equilibrium constant is applicable only when concentration of reactants and products. I have obtained their equilibrium state. So we have learned about this when we are comparing what is QC and KC. Okay. And we also know the equilibrium constant, it will be independent of initial concentration because at some point it is ratio. So when you have ratio, that means it's going to be constant. Then equilibrium constant has a definite value for every reaction at a particular temperature, because if you change the temperature, then you have seen that Kp and Kc, they all will depend on the temperature, right? And for a reversible reaction, the equilibrium constant of forward reaction is the inverse of. So you write these points. Let me know if you have doubt in any one of them. Let me maybe scroll a bit. Yeah. Let me know if I need to scroll down.
Sir, could you scroll down